In this video, I'm going to show you the best blockchain application for beginners to build and how to build it step by step. And you don't have to know anything about blockchain in order to get started. I'm going to show you everything as we go. So before we get into that, if you're new around here, hey, I'm Gregory from Dapp University. On this channel, I teach you how to become a blockchain master. So if that's something that you're interested in, then click the like button down below and click subscribe. And also, if you've been watching this channel for a while, don't forget, Blockchain Mastery University opens up in just a few short days. All right, you can click the link down below to sign up. So let me show you the best app for beginners to build and tell you a little bit about why I'm making this video. So blockchain development is, very complicated, and it's really easy to get overwhelmed by all the moving pieces involved. So I wanted to make a tutorial that removes some of that complexity so that you can understand better without all that extra stuff in the way. So we're not going to use any fancy frameworks, and we'll install very minimal items on our computer in order to get started. The first dependency that we'll install to build the project is Ganache. So Ganache is a one-click blockchain, as you can see here. Essentially, what this allows you to do is create a blockchain on your computer and just turn it on. And once you've started this app, you'll have a blockchain running. So really quickly, since this is a total beginner tutorial, what is a blockchain? A blockchain is basically a peer-to-peer computer. Okay, it does a lot of the same kinds of things that a regular computer does, whether that's on your desktop computer, your laptop, or a web server, right? It stores information inside of a database, and it also runs programs just like your computer does. And you can, simulate what a blockchain does with something like Ganache, and that's exactly what we're going to use it for in this tutorial. We'll create some smart contracts and put it on this blockchain, and we will connect to this blockchain with a website that we'll create, which you'll see momentarily. So go ahead and download Ganache. You can select your operating system, click the download button. Once you've downloaded it, go ahead and install it. And once you've installed it and open it, you will have a blockchain running. You'll see something like this. I would just recommend clicking Quick Start, okay? And once you do, you'll see that you have several accounts listed already. And each of these accounts has already been credited with 100 fake Ether. And also, I'll note that this blockchain mimics the Ethereum blockchain, and that's the one that we're focusing on this tutorial. So the next dependency is MetaMask. So MetaMask is an Ethereum wallet. And essentially what it's going to do in this tutorial is turn our web browser into a blockchain browser. So most web browsers don't connect to blockchains out of the box, and you need a special browser extension in order to do this. So that's exactly what MetaMask does. So you can just click install here if you haven't installed it yet, and it'll appear here, and you'll see the little fox icon once you've installed it. So those are all the dependencies that we need to get started. Let's go ahead and download the starter code for this project so that we can get started really fast. So I've included a link in the video description to this GitHub repository. This is where you can find the code. So you can either download this with Git if you know how to use Git. And if you don't know how to use Git, that's okay too. You could always reference these files and copy and paste them, or just copy the code by hand, whatever you want to do. If you want to code it out step by step, that's fine. But I've included the project code here to help us get started really fast. Okay. So if you know how to use Git, I would just copy this URL, go to your terminal, and type git clone, and then just paste in this URL here. All right, I've already done this, so I'm going to skip this step for now. So if you're not familiar with Git, you don't know how to do that, you could just create a project folder, called whatever you want to, and just make sure you include two files, this index.html file. And honestly, that's all you really need, which you'll see here in a minute. Okay. All right, now I'm going to enter into the project directory. I'll say cd ultimate. All right. And then I'll open this in my text editor, which in this case is Sublime Text. That's just a special command I have configured on my computer to see this. All right. So once you downloaded that, you'll see the basic project code inside of here. All right. It's not too complex. Everything we need to do really on our computer is all in one file here. You'll see this extra file here, greeter.sol. We're actually going to build this out here in a second inside of the smart contract editor, which I'll show you in a minute. Okay, so just make sure you have a way to get this on your computer first, all right? So now let's go ahead and start building the blockchain part of this tutorial. Head on over to remix.ethereum.org to get started. Okay, so Remix is a browser-based IDE for smart contract development, or blockchain development, whatever you want to call it, right? So once you get inside of here, you'll be able to create smart contracts. You can see some, you probably already have a few files here listed on the side, this file browser. You might see like a ballot.sol. So these are Solidity files. Solidity is the programming language that's used to write Ethereum smart contracts. Talk about that more in a minute. But this is all the code for the Solidity files. You can store as many files over here as you want to. You can create a new file like this with this plus button and go ahead and create a new one called greeter, greeter.sol. All right. So I've already got one. I'll just go ahead and clear the code out here. Inside this file is where we're going to go ahead and write the source code for the smart contract that we're going to use for this application. Okay. So like I said, we're going to do this with the Solidity programming language. So I'll point you to the documentation for that. So Solidity is a very beginner-friendly language. It looks a lot like Python or JavaScript and also C++ if you're familiar with any of those programming languages. If you're not, that's okay too. You'll be able to pick up on it pretty quickly in this tutorial. And you can use this guide as a complete comprehensive reference for the Solidity programming language. But I'm going to teach you the basics in this tutorial, okay? So in order to create the smart contract, let's go back here and just do the very first thing, which is required for pretty much all Ethereum smart contracts. We're going to declare the version of the Solidity programming language that we're going to use. All right. So in this case, we just say pragma Solidity caret version 0.5.0. All right. And put a semicolon after that line. I'm going to see if I can bump this up here so you can see it better. All right, so what we're going to do is create a smart contract called the greeter contract. And this is a famous smart contract example. You can find it like on the Ethereum website and stuff like that. So essentially what it does, it's very basic. What it's going to allow us to do is return a greeting. So we'll be able to call a function and it'll tell us what the current greeting is. And then we'll add our own functionality to this where we can update what that greeting is. And then we'll be able to call the function again and see the new one. Okay, so it'll make sense as we build this out, but it's pretty simple. So we'll create the contract like this. We say contract greeter. All right. And then we use these curly braces. All right. And that's it. That's the enclosure that we write all our source code inside of. All right, you choose the contract keyword, you give it the name of the smart contract, and then all of the rest of the code goes in here. All right. So now we can create the first line of code like this. We say a string greeting. All right. So this is really basic, and what this does is this creates a variable. All right, and it's a variable type of string. So let me explain that. A string is just a string of words, right? So if I do something down here, this is not smart contract code. I'm just showing you some code so that you see. So hello world, right? This is just a string. It's just a data structure that's just like plain text wrapped inside of quotes, right? So that's exactly what Solidity expects inside of this variable here, that it's string type. All right, so Solidity is a statically typed language, which means you have to tell it the data type whenever you're declaring a variable. We can't change this to a number or something like that, okay? So anyways, here's where we're going to store the greeting. And the special thing about this variable is it's called a state variable. So whenever we update this value, it's actually going to get stored to the blockchain, okay? So we can set the default value for this as hello world, all right? And then whenever we access this later, it'll be hello world by default. If we hadn't set this, it would just be empty, okay? So now let's create a function to read this variable. So what we can do is create a function like this. We use the function keyword, function greet. All right, and then we use these parentheses right here. And then inside of here, we can just say return greeting. All right, that's the basic function. All right, we basically just take the state variable, which we have access to inside of here, and we return it with this function. Now we're going to call this a getter function, which basically means it's just reading a value from the blockchain. It doesn't change the blockchain in any way. It just returns this information. So we need to add some modifiers to this, all right? We want to read this outside the smart contract, so we must call this public, all right? And because it just reads information, it doesn't write any information, we're going to say it's view, all right? And then next, we're going to specify the variable type that it returns, or the data type that it returns. We say returns string memory. All right, so it just returns a string. Now let's create a function that updates this greeting. All right, we do that like this. We say function set greeting. All right, and then inside of here, what we'll do is just say greeting equals some value. All right, so what we need to do is pass in an argument here and assign it to this state variable value. Okay, so we can create function arguments like this. We can just say string greeting, all right? And then we can assign the greeting like this. Remember, we needed to use a semicolon after this line. All right, so we pass in this greeting with an underscore, which is different from the greeting without an underscore. All right, we just assign it here. So the underscore really just makes sure that these variables are different and doesn't get confused with this greeting, okay? And because this is a function argument of a string, we must do memory here as well, memory. All right. And because we want to read this, we want to call this function outside of the smart contract, we want to call it public, just like we did above. And then we also want to specify the return value. Let's return a Boolean. Okay, so we'll say bool. So a Boolean is just a data type that's just either true or false. Okay, and we can just say return true. Semicolon, all right? So that's it. That's all we need to create our first smart contract. This is a simple greeter contract. This is, a famous smart contract that's used in a lot of programming examples. So we'll just have this value hello world of the greeting that's written to the blockchain. We'll be able to read it with this function, and then we'll be able to update it to whatever we want to with this new set greeting function, okay? So let's go ahead and compile the smart contract. That's a necessary step before we run it. All this human-readable source code must be compiled down to byte code, which must be interpreted by, the computer. In this case, this is going to be the Ethereum virtual machine. All right, so let's go compile this. All right, so let's actually select our Solidity version. I'm going to use 0.5.0 since that's exactly what we specified here. Even I know there's a caret, but let's just be particular. Click compile. Okay, it worked. So if you had any trouble with this, if it doesn't compile, it'll probably tell you some errors. You can always copy and paste the source code out of this Git repository just to make sure it worked properly if you can't figure out what your error was. All right. So let's go here and let's deploy it. So what you want to do is let's do it inside the browser first. Okay. We can actually deploy this just directly in Remix. Click the JavaScript virtual machine. And what this basically does is gives you a blockchain inside your browser. Okay, you can deploy this greeter smart contract to Remix, essentially, just in your web browser and interact with it. And that's what we're going to do before we try to put it on our computer. Okay, so let's just click that, click deploy. All right, looks like it worked. And you'll see this deployed contracts box down here. Click the down arrow. And you'll see the two functions that we created, the set greeting and greet. All right, so let's click the greet function first, and you can see, boom, there you go, hello world. Awesome. So let's update it. Let's just say, we got to use a string here, so put it inside a string. Say, I love coding. Set greeting. All right, so that was updated. And let's click the greet function again to see if it changed. Awesome. I love coding. So there you go. We have successfully created this smart contract. We've compiled it. We've deployed it to a blockchain inside our web browser. So that's your first introduction to Ethereum smart contracts and how to build them inside your browser. So now let's take this and actually deploy the smart contract to Ganache so that we can create a web page that talks to this smart contract and actually build a full application. All right, that's the next step. So there's a few moving parts here. The first thing you want to do is go to MetaMask, all right? and you want to create a new network. All right, so you'll probably want to say custom RPC. We'll call this Ganache. All right, and you're going to find the URL. In this case, mine is running on http:// localhost 7545. All right, so I've already created this, so it's not going to let me do it again. But the whole idea is that you can just call it Ganache. You can do localhost 7545, and I wouldn't fill out any of the optional parameters unless you know what you're doing. All right, so once you do that, click Save, and then find it. You'll see Ganache down here, or 7545, depending on what you've done in the past. So I'm just going to click this one because I know port 7545 is what I want. And you might see Remix ask you to reload if you have MetaMask. That's okay. So we'll go greeter, it's still there, everything's good. All right. We'll go to MetaMask. All right, everything's good. So the next thing I want to do is take the first account from Ganache right here. You see this address, and we want to put this account inside of our MetaMask wallet. All right, why are we doing this? Well, we need to deploy the smart contract to a blockchain, and when we do that, we have to pay. All right, so don't worry, this is fake money, it's fake ether. It's not worth anything, but essentially, whenever you update the blockchain, you must pay a gas fee. Okay, that's because reading information from the blockchain is free, but writing to it costs gas. All right, and that's exactly what we have to do whenever we deploy the smart contract. So if you'll click this little key here, you'll see the account address and also this private key. So don't use this on the public mainnet. Everyone who's watching this video has seen this private key. Don't lose all your money. All right, so just copy and paste this from your Ganache instance and go back to MetaMask, and we'll go import account. See here. Let me try to find this. Create account. Import. Select private key. All right, paste it in and click import. So I've already done this, so I'm going to find what I want and click it here. So I'm going to do this extra step, settings. I'm going to reset the account. See advanced, reset account. And essentially all this does is clear your transaction history, which sometimes is required when you're using Ganache. All right, so you may not have to do that, but you're not going to lose any money or anything like that if you have real accounts in here. All it does is reset your transactions inside of this app itself. It doesn't disrupt the blockchain in any way. Okay, so that's done. Now we have everything that we need in order to deploy this smart contract to Ganache. So let's select the greeter contract, go back to the deploy step, or we can compile it first, still compiles. And then whenever we go to deploy, make sure MetaMask has localhost 7545, and then click Injected Web3 Provider from the Environment dropdown, okay? What this is going to do is select the Ethereum provider that MetaMask gives us. I don't want to go too in-depth on that, but it's essentially know that you're deploying with MetaMask in this case, all right? And you can see this account here matches the same account in Ganache that we just imported, AEC, and you see AEC here, all right? So let's deploy it. Just click this button, and you should see a MetaMask confirmation pop up on your computer. Click confirm, and boom, there you go. So this deployed just like it did the last time, and you can see the greet function. Let's click it. All right, you can see string hello world, and it'll set the greeting. I love coding. All right, set greeting. You'll see this MetaMask confirmation pop up again. Click confirm. Boom, done. Awesome. So, great. We've deployed our greeter contract to Ganache here. The next thing I want to do is create the website. All right, we're going to create the website that talks to Ganache and actually interacts with the smart contract there. Okay, we'll be able to recreate this functionality where we can actually see the greeting all the time on the web page and then update it. So go ahead and open up that index.html file from the project that you cloned. And let's go ahead and find this script tag. All right, we'll clear all this out. Okay, so basically take everything inside of here and just backspace, because we're going to build all this out by hand, and I'll show you step by step how this works. Okay, so just save that, and then I want to, in Sublime Text, I'm just going to copy this file, copy file path. I think we do it this way. Let's do it this way. I'm going to go to my terminal. If you're on a Mac, this works. If you're on Windows or Linux, basically you just need to find where this file is and open it in your web browser. On a Mac, I can say open dot. Oops, that's actually not what I wanted. Well, actually, that works just fine. Boom, there we go. So all you need to do is find your file path and open it in a web browser like Chrome, okay? So here we can see an interface already. We just see a form, okay? This is how we're gonna set the greeting, and whenever the greeting populates, we'll be able to see it here. So really quickly, I'll explain what's going on in this project. This is just an index.html file, all right? This is all the code we need to build our front-end app. And, in the project, you'll also see this greeter.sol file. This is just the smart contract that I've included inside the repo, just as an example. This file isn't actually going to talk to this file in any way, all right? This is just for reference. Okay, so inside this index.html file, it's just standard HTML, but we've got a couple of extra things that I want to point out to you, okay? So Bootstrap is the first thing. You can see this link right here. This is just to a big CSS file that's on a server somewhere. And what this does is includes the Bootstrap templating framework. Okay, so basically this is going to give us a bunch of nice looking UI elements for free so that we don't have to write style sheets ourselves, okay? So you can already see this, nice blue button that has some interactivity to it, right? It changes colors whenever I hover over it. Same thing with the form field. And it already is aligned, right? We have to write code in order to make that happen if we didn't have this out of the box. So Bootstrap is included here, the CSS file. If you go down to the bottom, you'll also see some JavaScript files that are included. So, here's the Bootstrap file for that. So jQuery is basically just a library that allows you to do JavaScript-based interactions on the page, which we'll see here later. And then also Web3.js is the JavaScript library that's going to allow us to talk to the blockchain. So that's what Web3 is. It's a JavaScript library that basically turns your website into a blockchain website, or your app into a blockchain app, okay? Just like MetaMask turns your web browser into a blockchain browser, Web3.js turns your app into a blockchain app, all right? So I'll show you how to set Web3 up and point you to some places in the documentation so that you can see how it works, all right? So the first thing we'll do is connect our website to the blockchain, all right? And we'll do that with Web3 just like this. We'll just follow a standard pattern that is specified by Web3 in the documentation. All right, we'll just say this, right? So if type of Web3 is undefined, then we create a new instance, else we create a new instance this way. So I wouldn't worry about coding this out by hand. You can literally just copy and paste this. A lot of developers are going to just copy and paste this anyway from the Web3 documentation. I'll just explain it really quickly. So Web3 takes an Ethereum provider from your browser. In this case, that's injected by MetaMask. And basically, if one doesn't exist, it creates a new one this way. If it does exist, it's going to create it like this, okay? So next, let's actually connect to the smart contract, the greeter contract that we created in Remix. So I'll show you how to do that with Web3, all right? So if you look at the Web3 documentation, and you can look at this Web3 ETH contract on the side and click on that, basically what Web3 is going to allow us to do is create a JavaScript version of the smart contract so we can call these functions like greet and set greeting, all right? But in order to create that JavaScript version of the smart contract, we need a few pieces of information, all right? So we create it like this. We're just going to actually copy this straight from the documentation, all right? And paste it here. And some of this is like pseudocode, like this. But essentially what it's telling you is it creates a new contract instance with all its methods and events based on its JSON interface object, all right? And here's the parameters. The JSON interface and the address, and then some options, all right? So let's forget the options for now and focus on these two required parameters, the JSON interface and the address, all right? So the JSON interface is basically just some data that tells Web3 how the smart contract works. It tells it like the functions that it has and things like that. And also it tells us the functions that it has and a lot more. All right. So it'll tell us for example, that, the smart contract has a set greeting function, that it accepts one argument, and then there's also a greet function that returns the greeting, okay? So we need that, and then we also need the address. So the address is just the location of the smart contract that's deployed to the blockchain, all right? So I'll show you how to get those two pieces of information. We'll start with the ABI, all right? So let's go to this compile step, I believe. Compile, all right, you see this button down here, ABI, click that, and it will copy it to your clipboard, all right? So I'm gonna go inside of here, and I'll say var contract ABI, say equals, and then paste it in here. Boom, there you go. You'll see this big array. So this is a JSON array. This is just the description of how the smart contract works. You can read through this yourself, and don't worry too much about if you don't understand all this for now. Just know that you need this. And then the next thing we want to do is get the address. And say var contract address. All right, and we'll go look here, go to the deploy step, and you can basically just click this right here. This is a copy. And then I believe this copies the address. Let me just remember. Yep, there you go, awesome. So this is the address of the smart contract on the blockchain. You'll notice this looks a lot like these addresses that you see inside Ganache. That's exactly right. So these represent users on the blockchain, and this represents the smart contract. So smart contracts can have addresses, users can have addresses. Basically anything that needs to be located on the blockchain has an address, okay? So now with these two pieces of information, we can create a JavaScript version. So we'll say, we'll pass in these two arguments, contract ABI, and then contract address, all right? And I'm gonna assign this to a variable. Let's say var contract, all right, equals this. And then for now, let's just console log it. It's console.log contract, okay? Save that, go back to the browser. Let's look at the greeter. Let's open the Chrome console. You can do inspect element if you want to, and then go to console if you're not familiar with how to do that. But here you'll see, you'll see the contract logged to the console here. And just to make sure, we can say, here is the contract. Yeah, here it is. Awesome, cool. So now the contract's wired up. What we want to do now is display the greeting. Okay, so we're going to call this function that we created inside of Remix, greet, all right? And we do it like this. Let's look at the Web3 documentation. You look here on the sidebar and go to methods.mymethodCall. This will show you how to call that function. All right, so I'll explain this more in a minute. There's two types of functions inside of Web3.js. There's call functions and send functions. So call is what you want to use whenever you are just reading information, all right? And send is what you want to do anytime you're updating or writing new information, all right? This is actually going to create a transaction. So we want to use call in this case. And how you do it is just say, take the contract we created, give it the method name here, and then pass in any parameters that you want, and then chain the call function with some options, maybe a callback. All right, so I'll show you how that works. So we'll say contract, which we've declared here. So I'll move this down a little bit. And also, sorry guys, I meant to bump this font up so you could see. Hopefully that's better. So contract methods greet, all right? So that's how you call the function, but you're not done yet, all right? This doesn't actually return the value. So you want to say call after that, and then this is going to accept a callback function. So let's say function, and first argument is any error that might occur, and the next is result. All right, and so now we'll just write all the result code inside of here. Okay, so the first thing we'll do is, we're going to update the greeting and put it on the page. That's what the result's going to be. So we'll say, we'll use jQuery, and we'll just populate this greeting here. All right, so you can see this H1 tag has an ID of greeting. All right, so if you don't understand jQuery, that's okay. Just kind of trust me on this one. I mostly want to focus on the blockchain part of this, just so you know you're not too bogged down with new details. So this is how you do it in jQuery. You do greeting, and then you say HTML. This is just going to replace all the HTML inside of there with result. All right, so let's just save that. Go back to the web page and see if it worked. Boom, there you go. You can see the greeting that we set inside of Remix. I love coding. All right, so that's great. All right, so next, let's actually populate this box to talk to the smart contract. All right, excuse me, whenever we populate this box and hit set greeting, it will talk to the smart contract and actually update this, and we'll be able to see it on the page. Okay. So in order to do that, we actually have to call the set greeting function, which returns, or excuse me, it actually writes to the blockchain. It creates a transaction, and because of that, we need to use a send method with Web3. All right, so if you click on this part of the documentation, you'll see contract methods. My method in this case is going to be set greeting, pass in the parameter, and then we call send with some options. And in this case, we're going to have to tell it who the contract is being called by, right? So we'll say contract methods set greeting, set greeting, and then pass in the actual greeting value. So we'll just say greeting. We'll actually set this variable here in a minute. It's not defined just yet. And then we'll say send, all right? So we say call here, and we say send here. In this case, we're just going to pass in who it's from. All right, we need to actually populate these options here in a second, and I'll show you how to do that. So we call this, we need the account. Okay, so I'm going to comment this out for a second, and we need to get the account from MetaMask. We need to do that because you have to sign the transaction whenever you send it to the blockchain. So we need to tell Web3 that this account is the one that's updating this form. So we need to fetch it from MetaMask first. All right, so we do that like this. We say web3.eth.get accounts. All right, and then we say then and function accounts, and I'm going to console log it. Console log accounts, just so you can see how it works. Okay. Refresh the page, and web3 eth get accounts didn't work. Oh, sorry, that's because I forgot an S here. So get accounts with an S, and refresh the page. All right, so console, all full of typos today, guys. Sorry. Console.log. All right, and there you go. Boom, you can see all the accounts here. So I'll point you back to the Web3 documentation to see how that works again. So if you do Web3, let's look at the eth namespace. Let's see here. Just look for it. Get accounts. Oh, this is contract, sorry. So Web3 eth get accounts. All right, yeah, here you go. So you can see get accounts. This is how you do it. All right, this just returns all the accounts that are connected to the node, or in this case, MetaMask, okay? So we fetched that. And the reason we need that is to, call the greet function and tell, Web3 which account wants to send the transaction, okay? So what I'm going to do is paste our code we wrote earlier inside of this callback, and I'll say from accounts, which in this case is an array, and I would just want to read the first account out of the list. All right, so accounts 0. Boom. All right. So that's going to be the first one. So if you're new to JavaScript, arrays are zero-based index. So when you put a 0 in here, that refers to the first one in the list. All right. So that should work. But what we want to do is call this whenever this form is submitted. All right. So we can do this with jQuery. We basically just say form, like this form here. All right. Form. We find it on the page with jQuery. Say form on submit. And we pass in a function, event, and then we're going to put this inside of here. So we need to do some jQuery magic first. We say event prevent default. Don't worry if you don't understand that. Essentially what it means is we don't refresh the page whenever the form is submitted. But let's get the greeting. So greeting, all right, which we want to pass in here, right, this greeting. Let's get it from this field value here. So here's the input, all right, we just want to read the value. Greeting equals input val, okay. And now we can just pass that in here. So first I'm gonna just comment this out, make sure our basics are covered, say console.log greeting, and then passing greeting. Go back to the page, refresh, new greeting. Let's just set it. All right, so new greeting here. Awesome, great. So that works. And before we continue, I'm going to remove all these console logging statements. Remove this one, then remove this one. All right, now we can uncomment this and take it out, and it should work. All right, I'm going to go ahead and clear out all this space. Refresh the page. Here is the new greeting. Set greeting. And there we go. Refresh the page and boom, awesome. Here's the new greeting. So that's it. So congratulations, you've just built your first blockchain application powered by Ethereum smart contracts. All right, you've learned a lot in this tutorial, right? You've learned how to create a smart contract with Remix, with Solidity. You've installed a blockchain on your computer. You've installed an Ethereum wallet and turned your web browser into a blockchain browser with MetaMask. You've learned Web3.js, you've learned Bootstrap, you've learned HTML, you've learned all kinds of stuff. So congratulations, you're on your way to becoming a real-world blockchain developer. So I hope you liked this video. Again, the source code is available on GitHub and the link down below. You can just, if you got stuck, you can reference any of this code and just copy and paste into your own project. So again, I hope you like this video. And if you're serious about becoming a blockchain developer, you can join my free training on my website to see how to become one. All right. So just head on over to dappuniversity.com/bootcamp if you're interested in that. All right. So again, subscribe to the channel, click the like button down below. And until next time, thanks for watching Dapp University.